Hello and welcome to Algebra 1 Test 6 Study Guide. Really glad that you're here to redo your test. You've made a good choice to come in, redo this test, and then raise your grade. So first part of it is just showing up and you're here, so that's good. My name is Mr. Sipple and we'll be going through the 10 problems that you'll find on the test. We want to make sure you know how to do it first, so that's what we'll do with the study guide. Then once you feel good about what you're doing, then you can retake the test and raise your grade. And we give you credit just for completing the study guide, and obviously you'll raise your grade by redoing the test as well. So let's just go ahead and get started. Let's begin by writing your name at the top right of your page there. And also some of you are coming from different teachers, so if you would just write your teacher's name so I make sure that I get the paper to the right teacher so that you can get credit for being here today. Just kind of let you know the format of how this is going to go. If you haven't been to tutoring before, you'll notice there's 3 columns. What I'll do is I'll do the column on the left side to explain to you how to do it, and then the columns in the middle and on the right side, those are for you to really kind of try and see if you understand it after kind of seeing the example on the left side. What you want to do is you want to try to do as much of this as possible on your own. If you just copy down what I write, then you're not going to learn as much that way. So you really do. You want to try to do as much of this on your own. Watch the video, then if you get stuck, you can pause, rewind, go at your own speed. Alright, so the test 6 covers systems of equations, and when you think of the word system, just forget about math for a second. What do you think about when you hear the word system? Well, I thought of a couple different examples. I was thinking of maybe a video game system such as Xbox, perhaps a home theater system, right, because there's several speakers, and probably in health class you've heard the word system. Whether it's the digestive system, circulatory system, nervous system, skeletal system, we could go on and on, right? So the idea is that there's systems within your body. Then so you think about, well, what does that word system actually mean? Well, that word system means more than one. So it's not really a home theater system if you just had one speaker. In your digestive system, you have more than one organ that helps you process your food. So when we talk about a system of equations, it's just a group of more than one equation. In the solution, what we're looking for, the solution to a system, is the point on the graph where the 2 lines cross. So what we're going to be looking at in the first part of this test is that we're going to be given 2 lines, and then all we want to do is we want to graph those 2 lines, and then we just want to see where they meet. So for instance, on this graph they meet right there. So that's the first half of the test, and then the second half of the test we'll look at, well, how would you solve this if you didn't want to graph it or didn't have graph paper? So that's kind of the 2 themes of the test. The first half is graphing, the second half is without graphing. Last thing to mention here is that there's 3 possible solutions, and we'll refer back to this. But basically what will happen is if you graph 2 lines, there's 3 possibilities. Maybe those 2 lines cross at one place. Maybe they don't cross at all because they're parallel. Or a third possibility is that, and it's kind of hard to see on this, but the third possibility is that you graph a line and then you graph the same line right on top of it. And we'll kind of explain a little bit further on what that scenario means. So let's go ahead and take a look at the first one. You got y equals negative 1/3 x plus 3 and y equals x minus 1. Now if you're redoing this test, I'm assuming you did well on test 4. Test 4 was the graphing test. So the only difference between what you did on test 4, the graphing test, and test 6, is you'll notice there's just 2, right? Because we said that word system means more than one. So there's just 2 lines that we want to graph, and we want to see where each one crosses. Well, just a quick refresher on graphing. Look over at the top right corner there. So when we graph, we're looking at something called Slope-Intercept Form. Slope-Intercept Form, it's kind of a GPS. It just gives you directions. It tells you where to go. The last number tells you where to begin, where you put the first point. And we always begin on the y-axis, and then the slope tells you how to move from there. And how you move is you move up if it's positive, down if it's negative, and then you're always moving to the right. So I'm gonna, just so I've got a little room to work, I'm gonna rewrite this. Not that you have to, but I'm just gonna rewrite it. And what that says, so let's graph the first one, y equals negative 1/3 x plus 3. So my y-intercept is a positive 3, so that says to begin. And we always begin on the y-axis, right? So we're going to begin at 3. So I'm going to go up 1, 2, 3, and again that's always on the y-axis. And then the slope tells me how to move from there. Well, the slope in this case is a negative, so I'm going to go down 1 and right 3. And it's always, always, always to the right. So down 1 and right 1, 2, 3. And then there's my first line. So all I need to do is just connect those 2 points, and I've got a line. Now it's a system, so what I'm wanting to do is I'm wanting to do this for more than just one equation. I'm wanting to do this for 2. Alright, well let's graph the other guy, see what that one looks like. I'm just going to rewrite this one, so I've got y equals x minus 1. Now one thing is that if you notice there's no, right away maybe you notice the slope. Well, if there's no number in front of x, there really is a number there. It's really a 1, so you might want to write that 1 in. And if a number's not, if the slope's not a fraction, you can make anything a fraction by putting in a 1 underneath it. So that would really be 1 over 1. Let's talk about the y-intercept. So you've got a y-intercept. You're going to begin. So we're going to begin at negative 1. So I'm going to start down there. And again, it's always, always, always on the y-axis. Right, this is what that, look over here on the right side. Begin on the y-axis. And the slope, let's see, it says 1. So down here on the bottom it says that if the slope is positive, that I'm going to go up. And if it's negative, that we're going to go down. So in this case it's positive, so we're going to go up. And I'm going to go up 1, right 1. So let me go up 1, right 1, and then I'm right there. Let me draw my second line, and again all we're looking for is we're just looking to see where these 2 lines cross one another. Now you notice my line's a little sloppy. I'm actually not doing this with a ruler. You know, I've got some graph paper there, but you know it's not perfect. But what you can see is that you could see that those 2 lines cross right there at that point. So the solution, it looks like you would count over 1, 2, 3. So the solution would be 3, and then count up 1, 2. So the solution would be 3, 2, and that would be my answer. Now let's say that you weren't able to draw a really straight line. Here's another thing that you can do, is that if you keep adding on points, like if I kept going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, right? And then same thing over here, we were doing down 1, right 3, down 1, right 3. So if you need to put in a couple more points, just so you can make sure you see where they cross, that's always a good idea to do that. And so your final answer would be 3, 2. Right? So that's all we're doing. So go ahead and pause the video now once you try number 2 on your own, and then we'll come back here in a second. We'll check it for you. I'm sorry, I didn't mean number 2. Rather, let's try that again. So number 1 in the middle, we'll get to number 2, but number 1 in the middle. So try number 1 in the middle. So should have number 1 done at this point. So we're number 1 on the left side, that is. So let's check number 1 in the middle. So should have got an answer of 4, 1. So when you graph these 2 lines, you should see they cross at 4, 1. Now, if you got that as a correct answer, great. You can go ahead and try number 1 on the right side, fast forward, and see what the answer is to that one. If you didn't get it correct, well then hold on, and I'll explain it, and then maybe the point at which you catch your mistake, that would be a good point then to pause it and see if you can do the rest of it on your own. So again, we're going to follow the same format for the rest of the video, which is that the middle problem, I'll show you the answer. If you got it right, great, fast forward, go on to the next one. If you didn't get it right, then maybe watch it until you catch your mistake, and then try to finish it the rest of it on your own. Alright, so let's try y equals negative 1/4 x plus 2. So we're going to begin, as we said, we begin at the y-intercept. So we're going to begin at 2. So I'm going to begin at 2. And then I've got a slope, it's a negative 1/4, so that means I'm going to go down 1 and right 4. So I'm going to go down 1, right 1, 2, 3, and 4. And then I want to connect my points. And I'm actually kind of drawing this line a little sloppy on purpose because I want to show you how you could still figure out the answer if you do just that, which is draw a little sloppy. And let's look at the other one. So you got y equals x minus 3. Actually, I want to give myself a little more room there. So y equals x minus 3. Same deal. You're going to begin at negative 3, right? Because that's that last number. You're going to begin at negative 3. So 1, 2, 3. And then the slope, same thing as the last one. If you don't see a slope, it's really 1. If it's not a fraction, it's really 1 over 1. So the slope on this one would be up 1 and then right 1. So let me go up 1, right 1. And I'm actually going to try to maybe draw this line a little sloppy. Let's see how that works out. Well, maybe not too sloppy. Well, but maybe though, too, if you see, it actually looks like it kind of crosses here. It doesn't look like it's not perfectly in the corner of that box. So what you can do is you just put in a couple more points. Up 1 over 1, up 1 over 1, up 1 over 1. So it actually really should be there, right? And then on the same thing, you could do down 1 over 4, which should be right there as well. So if you see where that crosses, maybe we make that down a little bit larger. Looks like it's 1, 2, 3, 4 to the right and 1 up. And again, your x goes first, then your y. So 4 to the right, 1 up. So your answer would be 4, 1. All right, so go ahead and pause now and try number 1 on the right side. Let's check the answer for you on number 1 on the right side over there. Should have got 2, 1. Now, the one on the right side, I'm not going to work out for you. I don't want to make it that easy for you. So the one on the right side, I will not explain. I will not show the work for. I will just show the answer. So that's where I want you to kind of start working through it. So the one on the left is me showing you how to do it. The one in the middle is we kind of do it together. And then the progression is that by the time you get to the right side, that's where you're trying to do it all by yourself, right? Because that's where we want to move towards, is being able to do these without any help. Now, if you get stuck, right, if you get to this point and you tried to figure it out and you just don't know, where you went wrong, then go ahead and raise your hand. Flag me down, right? Call me over there. I'll come over there and help you. So that's the reason why you're watching this video in the room, and I'm there as well, so I could still help you if you still get stuck. All right, let's move along to number 2. So number 2 is another graphing question. You notice maybe 2 things different here. One thing that's different is you'll notice the less than, greater than symbols, right? So you notice the inequality symbols. The other thing that's different is that these equations, these inequalities I should say, are not in slope-intercept form. So for us to be able to graph, we want it in slope-intercept form. So what we're going to have to do is we're going to have to switch this over to slope-intercept form. So let me show you what that would look like. And I'm just going to start with the first one here. So you've got 2x plus y greater than or equal to 2. Now let's think about what slope-intercept form means. If you look over there in the top right corner, slope-intercept form, y equals mx plus b. You notice how the y is by itself, and it's by itself on the left side, and then everything else is over on the right side? So that's what we want to do. So you notice over here, y is not by itself. Well, we want to get it by itself. So the way that we do that, and the way that we get rid of anything in algebra, is we do the opposite. So the opposite of a positive 2x would be to subtract 2x. So I'm going to subtract 2x from both sides. And then those things cancel each other out. Bring down the y. And then you've got a greater than or equal to. Now you look at this, you might say, oh, 2 minus 2, does that cancel? Is that 0? Well, here's the thing. These are not like terms. You can't combine a number with an x. These are not like terms. You cannot add, subtract these two terms. So the best that you could do is you just would bring it down. So I would rewrite this as negative 2x plus 2. And so all I did is I brought this down. So see, I took the 2 and I just brought it down. I took the negative 2x and I brought it down. Now why did I put it in that order? Why didn't I say 2 minus 2x? Well, look at slope-intercept form. See how it says y equals mx? So the x is in the middle, and the number that's by itself is by itself at the end. So that's why I would write it in that way. All right, so let's graph that one. So y-intercept of positive 2. Right, so we should feel pretty comfortable with that right by this point. And then you got a slope of negative 2 over 1. So remember, if it's not a fraction, make it a fraction. So what that slope means is it means to go down 2 and right 1. And it's always, always, always to the right. So down 2 and right 1. And now if this were a line, you just go ahead and draw the line and call it a day and you move on. But the thing here is this is an inequality symbol. So there's another decision that you have to make. You have to, first of all, and let's look over here at the right side. Which line do I draw? Do I draw a solid line or do I draw a broken line? Well, you draw a solid line if there's the or equal to part, right? The little line underneath. But if there's no line underneath, then you're going to draw a broken line. So let's look at ours. I see the line underneath there, so I will draw a solid line. So let me draw a solid line there. And there's one other decision, or one other question I have to ask myself, coming back over here to the right side. Which way do I shade? Do I shade above or below? Well, if you're talking about something that's greater than, something greater than you means something above you. If it's less than means something below, so you would shade below. Let's look at our symbol here. So our symbol is a greater than or equal to. So since I have a greater than or equal to, that means that I'm going to shade above. Now, how would I know which way is above? Well, just imagine you had a little hiker guy on the mountain, and we said, well, what's above him? So you think above would be above his head, so it would be everything that's this direction would be above. Because see, if you shaded this way, you'd be shading below his feet. Well, that wouldn't be right. You notice, by the way, I haven't got all crazy with the shading yet. I just did some lines like that because what we're going to be looking for is we're actually going to be looking for where these areas overlap. So I'm trying to keep it clean, at least just for the time being here. All right, so let's look at the second one. So that was our first inequality. Let's look at the second one. So this one says x minus 2y less than 6. So same deal. You got to get x over there. So I'm going to subtract x from both sides. And those x's cancel, and I've got negative 2y less than negative x plus 6. Now, on the one above it, you notice there was no number in front of y, so I really had to just do kind of one step and I was done. You'll notice a little different here is there's actually a number in front of y, so you're going to have to divide, because that says negative 2 times y. So you're going to have to divide everything by negative 2. Now, there's two real tricky things with this, so watch what's going to happen here. First of all, you see the negative and negative, right? So this negative, there's a negative and a negative. Well, those two negatives are going to turn into a positive. So that's actually going to turn into a positive 1/2 x. You might be wondering, well, where'd the 1 come from? Well, there was really a little 1 in front of here the whole time. I didn't write it in. Maybe we could have or should have. But yeah, so there's really a little 1 in front. So the negative would make a positive 1/2. 6 divided by negative 2, well, that would give you a negative 3. And there's one other thing that we have to pay attention to here, which is the inequality symbol. So if you recall back to test 3 and actually test 4, is that with inequalities that if you multiply or divide by a negative, you have to switch the inequality symbol. So that less than will turn into a greater than. Highlight the change there. So when I go to graph, this is actually what I'm going to be working with, is y greater than 1/2 x minus 3. And this was my other equation up here. So y greater than 1/2 x minus 3. So I'm telling you right now, the question that's on the test is exactly like this, where there's two things you got to watch out for. Two negatives, right? These two negatives are going to turn into a positive, and then you're going to divide by a negative, so the inequality symbol will change. Now you might wonder, why didn't we do that for this first one up here? Well, because we didn't multiply or divide by a negative. That's why it didn't change. So let's start with our y-intercept. You got a y-intercept of negative 3. So 1, 2, 3. So there's negative 3. And then you got a slope of up 1, right 2. So let's go up 1, right 2. And let's see, what kind of line am I going to draw here? So which line, looking over here at the right side, which line do I draw? Well, my symbol doesn't have a little line underneath it, so that means it's going to be a broken line. Broken, dashed, dotted, whatever you want to say. Alright, so it's going to look something like that. Now, which way do I shade? Well, I've got a greater than, and greater than means above. So these are actually both going to be shaded above. Now, if we're thinking about which way is above, here's a little hiker man on the mountain, and if we said which way is above where he is, it'd be everything above his head, right? So it'd be everything this direction. So now watch this. Hopefully it doesn't get too messy on you, but what we're going to do is that we're going to shade everything above. Now, what we're really looking for, however, is we're looking for the point where the two graphs cross over one another. So you see, like, there's only purple here, there's nothing here, there's only green here. Okay, the only place where there's purple and green is that whole area right there. So as far as where I would kind of darken in and shade things, it would be this whole area right here. So if you wanted to get crazy with your shading, you know, this is the point where then you could shade all of that in. Maybe try that with the... I don't know, that looks even worse. Whatever, you get the idea, right? So that's what we're looking for, is we're looking for where the two lines overlap one another, like where they share, right? Because again, this is only purple, this part of the pie down here, there's nothing there. This is only green, so where they overlap is that top piece right there. All right, so let's go ahead and pause now and try number 2 in the middle. Okay, so should have that finished by now. Let's check number 2 in the middle. So number 2 in the middle, the picture would look like that, where you have this, you know, kind of triangular-ish piece up to the top right shaded. Now, if you got that, great. Go ahead and pause and try number 2 on the right side. If you didn't get that correct, then hang on and let's listen to the explanation on that. And like I said, once you figure out maybe where your mistake was, don't let me do the rest of the problem for you. You pause it. You see if you can pick it up from there, because that's going to be the most beneficial thing for you, is if you try to start doing this as much of it on your own as possible. Think about training wheels on a bike. You only use the training wheels while you need it. Then you kick them off and you got to do it on your own. So think of me as training wheels. You know, I'm just I'm here to help you get it in the very beginning, but once you got it, you really got to try to do this on your own. So let's check number 2 in the middle, and I'm just going to kind of start from scratch or start from the beginning here. So again, we had 2 inequalities here that we had to solve for that are not in slope-intercept form. Again, slope-intercept form is this thing over here in top right, y equals mx plus b. We said that what makes something in slope-intercept form is the y is by itself over there on the left side, and everything else is over there on the right side. So what we would need to do is that we would first need to move this 2x. So I'm going to subtract 2x from both sides. And I get 3y greater than negative 2x plus 3. Remember we said that these are not like terms. A number and an x are not like terms, so all we did is we just brought it down. And we did it in that particular order because that's the order of slope-intercept form. The m and the slope, the x, is in the middle. Now y is still not by itself yet. I see a 3 here I've got to get rid of. That says 3 times y, so the opposite would be to divide by 3. So let's divide everything by 3. And I end up with y. Ooh, I don't know. Do I switch the inequality symbol? Oh, no, you know what? I didn't divide by a negative or multiply. So it would stay exactly the same. So I'd have y greater than negative 2/3. Actually, I want to scoot this down a little bit. So I'd have y greater than negative 2/3 x plus 1. So that would be the first inequality that I need to graph. So let's go ahead and do that now. So I got a y-intercept of positive 1, right? Remember my last number is where you begin. That's my y-intercept. So I'm going to start at positive 1. And then the slope tells me how to move from there. Number on top's a negative, so I'm going to go down 2 and then right 3. So down 1, 2, 1, 2, 3. And then I have to see if it's going to be solid or broken. Looks like I don't see a line underneath there, so no line underneath means that it's going to be broken. So I'm going to draw a broken line. And let me just draw a broken line here. And you notice my line's not perfect. That's all right. We're not going for perfection here. And then as far as which way am I going to shade this thing, so you'll notice that it is a greater than and greater than. Oops, let me fix that. Right, so greater than means above, so I'm going to shade above on this one. So let me mark above. And again, we know that that would be above if I had my little stick figure guy right there, and we said, well, what would be above him? It would be everything above his head, right? So that's how we would know that it would be that way. And then let's look at the other one. So got that one? Got that one? So let's see the second one. So x minus 3y less than or equal to 6. Okay, so we have to, same deal, subtract x from both sides. And you've got negative 3y less than or equal to negative x plus 6. They're not like terms, so you just bring it down. We said that's really like there's a 1 there. So when we go to divide by everything by negative 3, the negative and negative is going to make a positive here in a second. And so let's see what we'd end up with. All right. By the way, if you're wondering what just happened there, I paused it so I can move some stuff around so we had a little bit more room. So you're not crazy. All right. So let's see here. Y. And so we said there's two things that we have to watch out for. First thing that we need to watch out for is that the fact that we're dividing by a negative means that you're going to have to switch that inequality symbol. So that less than or equal to is going to turn into a greater than or equal to. And then the other thing to watch out for is that you have two negatives here. You got a negative and a negative, so those two negatives are going to turn into a positive 1/3 x minus 2. And then so that will be our second inequality that we need to graph. Let's begin with our y-intercept. There's our y-intercept, negative 2, so we're going to begin at negative 2. And let's check out our slope. Positive 1/3, which means to go up 1 and right 3. So up 1, right 3. Oh, they cross right there. Let's check to see if it's solid or broken. So if you look over here on the right side, I see a solid line underneath mine, so I know that's going to be a solid line. So let's connect. Whoa, that's not even close. Let's connect those 2 points. A little better. And let's see what the shading on this one says. So this one says greater than, so greater than means above. So I'm going to shade above on this one. So let me shade. And again, what we're looking for here is we're looking to see where the two lines cross over one another. The part of the graph that is both green and purple at the same time. Well, the only place that that happens is this area right here. Because so you notice, look at the other parts of the graph. This little part right here, that's green only. This bottom part, there's absolutely nothing there. This part over here is purple only. So the only part that's both purple and green is that top part right there. All right, so hopefully you're feeling a little bit better about it at this point. So go ahead and pause the video now and try number 2 on the right side. Let's see what you got with number 2 on the right side. So the graph should look something like that, where you have a y-intercept of positive 2, and then you have a y-intercept of negative 1, and then the shaded area is in between those two lines. Now, if you're not sure how I got that picture, then pause and then ask for some help. Try to figure it out first, but then if you don't have it, pause. All right, so let's move on to number 3. Now, number 3 and 4 actually are kind of the complete opposite or reverse of what we just did. What we just did is they said, hey, here's some lines, you make the picture. So now this is kind of the complete opposite. This is saying, hey, here's a picture. What were the equations that made that? Like y equals something x plus something, right, whatever the y-intercept was be. So that's what we're trying to figure out here. Well, this is actually a whole lot easier than graphing, because the picture's already made. All we got to do is just look at the picture. So I'm going to, for this one here, I'm going to say that's the blue line right there. Well, you know how we said that, the slope and the y-intercept, you look at the y-intercept first, that's where you begin. Well, let's take a look at where they started, right? If you look at that blue line, starts at a positive 1, so my y-intercept would be a positive 1. Look how easy that is. Now, to figure out what the slope is, all I've got to do is I just got to follow the line to where it goes through the next corner. So you see where it goes through a corner right there, and then I just have to figure out, well, how many up and how many over was that? Well, it looks like you'd go up 1 and then right 3, right? Because that was up 1 and then right 3. So then that would be a slope of 1/3. How easy is that? That's it. And then let's just do the same thing for the other graph. So if you look at the other graph, and we'll do the red line, we'll say that's this one right here. Right. So let's look at the y-intercept. Let's see where they started. Looks like they started down here. Now that would be 1, 2, 3, 4, and that's down, so it'd be a -4. So y-intercept of -4. And then let's check out the slope. If I ride the line up, and by the way, we're always, just like you read a book from left to right, we always look at the graph from left to right. So you notice that in this case I'm riding the line up because that's moving towards the right. And this other one, same thing, I was moving towards the right, so that's why I was going that direction. So looking for a corner, and what I mean by a corner is the point at which the line goes through the corner of the box. Right, so that's not a corner because that goes kind of halfway through the box. So I just need to kind of keep going up. There's another corner. And then all I'm doing is I'm just counting to see how many up and how many over. So to get from there to there, looks like I would go up 2 and right 1. So what that would mean is that my slope would be 2/1. Now what I'm going to do for my final answer, I'm going to kind of clean this up. One thing that we do, by the way, is, and you notice this maybe on the other one, you notice these kind of funny looking parentheses. They're actually not parentheses. It's actually called a brace. It's kind of like a parentheses, and in the middle there's a little nose, pointy nose that sticks out. So that's what we call a brace. And it's just a fancy math symbol we use to put a system together, right? Because we said system in a group. So that's all that brace says is, hey, it says, hey, this is a group. So I'd clean it up and I'd write y equals 1/3 x plus 1. And y equals 2x minus 4. And that would be my final answer. I said clean it up. What I mean by that is that, yeah, true, it's 2/1, but when we write our final answer, anything divided by 1 is just itself. So that's why we would just write 2. All right, easier stuff. At least, definitely, I think a lot easier than having to graph it yourself. All right, so go ahead and pause now and try number 3 in the middle. Taking a look at number 3 in the middle, should have got y equals 3/2 x minus 4 and y equals -2x plus 3. By the way, I didn't mention on the other one, but the order doesn't matter here. So, if you would have written -2x plus 3 first on the top and vice versa, right, so the order doesn't matter there. Don't worry about that. So if you got that right, great. Go ahead and pause it. Try number 3 on the right side. If you didn't get that right, then let's kind of walk through the explanation on that one. So again, we're looking for the description of this particular line, right? So this line has a name, just like you got a name. This line's got a name. So we're just trying to figure out what this line is, how we describe it in terms of what's the slope and what's the y-intercept. And so all we have to do is really just look at the picture they already made. You know that we begin with the b, right, the y-intercept. So I'm going to look at, let's see, 1, 2, 3. So my y-intercept is 3. And then my slope, again, you're always looking from left to right. So if I was moving towards the right, I'm looking for the next place where the line goes through a corner. It's like it goes through right there at that point. And then so if I look to see how many, it looks like it goes down 2 and right 1. So because it goes down, that would be a -2 and over 1. And again, the distance over is always going to be a positive number. So what I would write in there for my slope would be a -2 over 1. Now let's look at the other line. Again, starting with the y-intercept. Looks like it's at -1, -2, -3, -4. So that would be a y-intercept of -4. And then let's look at the slope. If I ride that line up, that's not a corner, not a corner, corner. Right, so that works. And then let's see how many up, how many over that one would be. So it looks like it goes up 1, 2, 3, right 1, 2. So that would be up 3, right 2. So that would be a slope of 3 over 2, or 3/2. And then so if I were to go ahead and write that using the braces, little nose sticking out, so I'd have y equals 3/2 x minus 4, and y equals negative 2x plus 3. Alright, so go ahead and pause now and try to do number 3 on the right side. And like I said, by the time you get to the problem that's on the right side, you should be able to do this on your own. At least that's the idea. Alright, so let's see what you got with number 3 on the right side. You got y equals 1/3 x plus 3 and y equals negative 2x minus 4. And I didn't mention on that last one, but make sure that you really write in the points. You see where I put in, I'm bubbling it, putting that in right there, right? So that way it's easier for you to count, that you're actually marking the points. Alright, so let's look at number 4. So number 4 is pretty much the same thing that we just did. The only difference is it's inequalities, right? There's shading. So we just have to, you notice that my little boxes that I had filled in here, I got a new box. So my new box says symbol. And what that means is I have to decide, is it going to be less than, is it going to be greater than? So I kind of have an extra decision there. So let's take a look at this, right? So we'll do that one, the blue line first. Doesn't matter where we start. But we do know that we always start with the y-intercept. So that's up 1, 2. So now my y-intercept would be a positive 2. And then let's look and see what the slope would be. The slope is how many up, how many over to get to the next corner. So I'm looking for the corner, and that's a corner. And so then if we said, well, okay, how many up, how many over? Looks like I would go up 1, right 2, up 1, right 2. So then that would be a slope of a positive 1/2. And then the only other thing we got to decide here is we got to decide what the symbol is going to be. Is it going to be less than, greater than? Well, first of all, let's figure out if it's going to be solid or not. So you notice that I've got a solid line right here. So we said for a solid line that it's going to have the equal to underneath it. So right away I know there's going to be a line underneath it because it's solid. Now let's look at which way this thing is shaded. If I look to see where this thing is shaded, it is shaded below, right? It's shaded below that blue line. So you know that below means less than. So that would be y less than or equal to 1/2 x plus 2. Now all we have to do is just do the same exact thing for this other line, this red line. So let's look at what the red line would be. Again, starting with the y-intercept, so hopefully you should be feeling pretty good about that idea of the y-intercept at this point. So it looks like a y-intercept of negative 3. Check it. Look for the slope, looking for a corner, corner, corner. There's a corner. And then we want to look to see, well, okay, well, how many up, how many over? Looks like it goes up 1, 2, 3, and then right 1. So that would be a slope of 3 over 1. 3 over 1. And let's figure out what's happening here with the line. You notice that line is a broken line. So we know that if it's broken, there's not going to be any line underneath it. And then I've just got to figure out which way this thing is shaded. Well, if we looked at it, this thing is shaded below the line. They're actually both shaded below. So then that would be a less than. So when we clean it up, because we're going to put it in the braces, I've got y less than or equal to 1/2 x plus 2 and y less than 3x minus 3. So really the same thing that we did on number 3. The only difference here is that we had an extra decision to make, which was, what's the inequality symbol going to be? But otherwise, really the same idea. All right, same routine. Go ahead and pause now. Try number 4 in the middle. All right, well, let's take a look to see what you did with number 4 in the middle. Number 4 in the middle should have got y greater than or equal to 2x plus 1. And y less than negative x minus 2. And you might have also written a negative 1. That's okay. Same thing, right? So that either way, that would be the same answer. If you got it right, great. Air high five to you. And go ahead and pause now and try number 4 on the right side. If you didn't get that right, well then let's walk through the that problem to see maybe where you went wrong. So starting with the y-intercept, right? That's where we begin. Right? The reason why I keep saying begin, I'm not trying to be annoying, I promise. It's just to help you remember that in y equals mx plus b, the b tells you where to begin. The m tells you how to move from there. So just a little memory trick, that's all. So let's look at the y-intercept there. So let's see, blue line, +1. Check out the slope. How many up, how many over? There's your corner. So it looks like that we're going up 2 and right 1. Up 2, right 1. So that would be a slope of 2 over 1. 2 over 1. And then let's check out what the symbol would be. That looks like a solid line, right? So no gaps in it. So I can tell you right now there's going to be a line underneath it. And then let's see which way this thing is shaded. So if you see where it's shaded, it's actually shaded that way. So it's shaded above the line. So we know that above means greater than. So that would be y greater than or equal to 2x plus 1. Let's check out the red line. So y-intercept right there. And that looks like a -2. Slope, let's keep riding the line down to the next corner. Hey, didn't have to go too far. So it's actually in the very next box is where it crosses the corner, right? So that actually would be down 1 and right 1. So the slope on that would be a -1 over 1. -1 over 1. And symbol, see symbol, it's a broken line. So I know there's not going to be any line underneath it, so no line. And let's check out which way this thing is shaded. So again, for this red line, it's shaded below. How do I know that's below? Well, this is above, and it's not shaded over here. So the only way that that could be shaded is shaded below. So below, which means less than. So I'd have a symbol that looks like that. So when I go to clean it up with my braces, I've got y greater than or equal to 2x plus 1 and y less than. And this is where I said, you could write -1x, you could write just -x, because -1 divided by 1 is just -1. So you could write this, you could write -1x. But that's probably not how you'll see it, because, negative 1 times anything is just itself, and so the 1 would disappear. So more than likely, you'd see it written this way, which would be -x. Now, if you leave it with -1, that's absolutely fine. Leave it with -1x. You may even want to do that to help you remind yourself there is a 1 there. But I'm just trying to let you know how you kind of would see it on the test. All right, so pause now and try number 4 on the right side. And let's see what you got for number 4 on that right side. So it should have got y less than -2x plus 3 and y less than or equal to 1/2 x minus 2. All right. Well, so I got some bad news for you. I know you're going to be disappointed here, but we're actually done with the graphing. I know you're probably very broken-hearted about it, but no more graphing. Now, I showed you this at the beginning, right? We said a system is a group of more than one. The solution to a system is the point where the two lines cross, right? So that's what we've just been doing on those last 4 problems, is looking at the graph and seeing where does it cross. Well, but here's the whole deal, though. Like, there's graph paper, and, because you have graph paper, you got the little graph on your paper, right? I've got graph paper up here on my board. But then the thing is like, well, what if I don't have graph paper? I don't have a straight edge. What if I hate graphing? Which you don't, you really secretly love graphing, but because it's really, really easy. But if you don't want to graph, what's a way to figure out where these two lines cross without actually having to graph? Well, that's the second half of this test that we're going to look at, are ways of figuring out where two lines cross without actually graphing. So let's take a look at this first system. So you've got y equals -2x minus 7. And y equals -6x minus 15. Now I could graph that, but maybe right away you kind of see the problem with graphing this. Don't write this down. I'm just going to show you something real quick. See how that's got a y-intercept? If we were talking about a y-intercept, see that's got a y-intercept of -15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh my gosh. Right? So like that's just way too much to try to count. So you imagine if that was a larger number. So this is one of the limitations of graphing, is what if you're talking about numbers that are maybe too big to put on a graph, right? So we want another way. So get that graph out of there. Well, so the other way that we're going to look at is that this first method we're going to look at is called substitution. Substitution. Now again, that's not just a math word. If you think about sports, right? If you have a substitute, it means that someone goes in the game, someone's coming out of the game. Even at school, you have a substitute teacher. Your teacher's not there one day. Someone else substitutes for your teacher. Go to a restaurant. You're trying to eat healthy. You don't want the fries. You substitute a salad instead. So substitution just means to replace. If you substitute something, it just means that you're replacing it. So what we're going to do is, you notice there's two equations because it's a system. That's what system means more than one, right? And then so what we want to do, maybe it's a little bit bigger. There we go. What we want to do is that we want to substitute or replace one of the equations into the other. So what I mean by that is that I'm going to take this whole equation, negative 2x minus 7, because see it says y equals negative 2x minus 7, and I'm going to substitute, or I'm going to replace it in for that y. And the reason why, by the way, you notice on the top right over there, I got the little bear with the thing that is like rigged that you can never win. Because it's that idea of, you imagine that arm going down to pick up the bear, and then it comes across, and you're trying to drop it over to where you can get it. Same idea here. Imagine kind of picking up that claw, negative 2x minus 7. We're picking it up and we're moving it, right? We're picking it up and we're moving it right there. So what I could write would be negative 2x minus 7. And then the second part of that stays exactly the same, negative 6x minus 15. Maybe another way to think of this is I kind of stuffed one equation, picked one equation up, and I stuffed it into the other equation. Or I combined the two equations is maybe another way to think of it. Because see, now instead of having two separate equations, I have just one big equation. All right, so what I want to do from there is I just want to solve for x. And so what I can do is I want to get all my x's together on the same side. So I know in the final end of it all that my answer is going to be, x equals, whatever number. So I know the x is going to be on the left side, so I have a habit of wanting to move all my x's over there anyways. So the opposite of a negative 6x would be to add 6x. Negative 2 plus 6, you have more positives than you do negatives, so that would be a positive 4x. Minus 7 equals negative 15. And then you're just trying to get x by itself. So you get rid of the numbers that are on the same side. We always get rid of the constant first, with the number that's by itself there. And we're always doing the opposite. So the opposite of a minus 7 would be a plus 7. Those cancel. And then I've got negative 15 plus 7. Now it's real easy, by the way. I'm just going to go ahead and mention this now. With the next set of problems that we're looking at, it's really easy to make one tiny little arithmetic mistake, and then you screw up the rest of the answer. So be real careful when you're adding, right? So what do you have more of? You have more negatives. That's what you ask yourself first. What do I have more of? Do I have more negatives, more positives? I have more negatives, and then you say, well, how many more negatives do I have than positives? Which means you have to subtract, right? 15 minus 7, which would be 8, and they're not 8 positives, they're 8 negatives. Now the last part of that, and we'll get this out of the way. Last part of that, x is almost by itself. So I would have to divide both sides by 4. And I get x equals negative 2. Okay. Well, so now I know what x is. But when we write our final answer, we're looking for the point where the two lines cross. So we want our answer written in terms of x comma y. That's what we want our final answer to look like. So I know what x is. Now I just have to figure out what y is. So I can replace or substitute x into one of these equations. It does not matter which one. Just pick one. I always say pick the one that looks easier. So what that means to me is maybe stay away from some negatives, maybe some smaller numbers. So I'm going to go with the first one. But again, I do want to stress that it does not matter which one you pick. So I've got y equals negative 2x minus 7. But see, I don't need to write x anymore because I know what x is equal to. It's equal to negative 2. So I'm going to substitute. Here's that claw, right? The claw picking up, and I'm going to drop negative 2 off right there. So I'm not going to write x because I know what x is equal to. It's equal to negative 2. And then, so I've got y equals negative 2 times negative 2 minus 7. And then we're just going to crank this out. Negative 2 times negative 2 would be a positive 4. I have more negatives, and 7 minus 4 would be 3, so that would be a negative 3. So there's my answer. So I've got an answer of negative 2, comma, negative 3. Those two lines, if I graphed it, cross at negative 2, negative 3. Now I just want to show you something. I've got my graphing calculator already kind of queued up here. I've got those two lines in there, and I just want to graph it. And I want you to see that, you know, I'm not just making stuff up here. That if we graph these two lines, they really do cross at those 2 points. There's your first line. There's your second line. And so you see where they cross. They cross in that area right there. So -2, -3. Right? So that's where they cross. So we figured out where they crossed without actually having to go through the trouble of graphing. So that's all that means. All right, so pause now. Try number 5 in the middle. All right, well, let's see what you got with number 5 in the middle. So number 5 in the middle should have got 1, -4 as your answer. 1 for x and -4 for y. If you did get that, awesome. Go ahead and pause now. Try number 5 on the right side. If you didn't get that, then let's take a look and see maybe what happened there. And again, once you find your mistake, like let's say you catch your mistake, as soon as you catch your mistake, pause the video, try to do the rest of it on your own. Again, we're trying to get you to do as much as possible on your own. All right, so we're going to substitute. Again, substitute just means replace. I'm taking one equation, and I'm stuffing it into the other equation. A couple things here. You might wonder, well, why are you putting it in for the y? Well, because it says y equals -3x, right? So that's why I'm not dropping it in on the x, because that doesn't say x, it says y. The other thing is that I could, it's not always just the top into the bottom. So just so you know, and I didn't mention this on the last one, but just so you know, what I could do, what happened? There we go. All right, we're back. What I could do is I could take what's on the bottom and plug it in on the top. So I can do that as well. So I don't want you to think that it's just, you know, the top going into the bottom. I could go that other direction as well. Again, it's probably just maybe a little bit out of habit of doing it this way. All right, so we're going to combine those two. So you got -3x minus 1 equals 8x minus 12. And again, we want to get all of our x's together on the left side over there. That's a positive 8x. So how we move a positive 8x would be to subtract 8x. What we do to one side, we do to the other. What do I have? Well, I don't have any positives. I've got 3 negatives, and now I've got 8 more negatives. So that would give me a total of 11 negatives, right, because I'm adding those together. And let's see, I want to get rid of this -1. The number the coefficient, the number in front of the variable, we always get rid of that last. So you always add or subtract before you multiply or divide. So we end up with a -11x equals, let's see, what do I have more of? I have more negatives than I do positives, so I know the answer would be negative. And then if I said how many more negatives than positive, you know, if you're trying to find the difference between two things, you're subtracting, right? That's why we use that word for subtraction, the difference. So that would be a -11. And then let's divide both sides by -11. So you get x equals +1. Now again, you just pick one of the equations. It doesn't matter which one. I'm going to go with the top one. Just numbers look a little maybe nicer, a little smaller. Again, it does not matter which one you pick. I know what x is equal to now, so I'm going to drop x in right there. So instead of writing x, I'm going to write a +1. And let's see, we got -3 times 1, which would be a -3. -3 minus 1. I have 3 negatives. Now you're telling me I have 1 more negative, so I've got a total of 4 negatives. So that's where we'd get y equals -4. Right? All right, so go ahead and pause now and try number 5 on the right side. And should have number 5 done at this point, so let's see what you got for number 5. Number 5 on the right side should have got 1, -1. Right? So make sure that you're doing the ones on the right side over there, and make sure you have those complete, because I'll check those before you actually can retake the test. All right, well, more than halfway done. Hang in there. Number 6. So let's look at number 6. So that says y equals -4x minus 5. 12x plus 3y equals -15. All right, so same deal. I've got, and I should mention maybe one thing real quick. You notice that on number 5 that these were both in slope-intercept form, y equals mx plus b. If you look at number 6, you'll see that one is in slope-intercept form, but the other is not. That's okay. We don't have to move this around because we're not graphing it. So we don't have to move that around into slope-intercept form. When we go to pick up our y with our little claw there, -4x minus 5, we're going to drop it off right there. Okay? And again, we're doing that for the y because it says y equals. Now, what I would do is I would go and copy the equation as it is, 12x plus 3. The difference here this time, though, is I'm not going to write y. I'm going to write what it's equal to, which would be a negative 4x minus 5. Also, you'll notice that I put parentheses around where I'm doing the substitution, because that says 3 times y. So when I multiply, I have to show that distribution, right? I have to show that I'm multiplying. Equals negative 15. And again, I'm doing this in two different colors for you because I want you to see, what's already there. What I'm writing here in black, that's the second equation that's already there, 12x plus 3. And then what I'm writing in red is just the one thing that's different, is I'm substituting, or I'm replacing y. Y's going out of the game. And who's coming into the game for y would be negative 4x minus 5. Now, I can solve for x from there, so let me distribute. Got a positive 3 here that I need to distribute. So that would be 12x minus 12x minus 15 equals negative 15. Wait. Right, so something should start looking kind of weird here. 12x minus 12x, wait, that cancels. Right, because 12x minus 12x would be 0. And then the only thing that's left over is negative 15 equals negative 15. Then it's like, wait, how am I supposed to solve for x when there are no x's? Well, so this is a special case, what we call a special case with these systems, which is that when either the x or the y are eliminated from the problem and all you're left is one number equal to another number, what you have to look at is and you'll notice in the bottom right-hand corner here, you have to look at, is what's left over, is it true? Is that a true statement or is it a false statement? True meaning, do the numbers match? Are they the same numbers? Is negative 15 equal to negative 15? Yes, that is true. So what that means about this particular line is that they're actually the same line. So if we were to graph these two lines, what we would find is that it's this situation over here where they're actually the same line. So if we said that what's that infinite many solutions mean? Well, remember we said the solution is where they touch. So if they only touch in one spot, that's your one solution. Or if they don't touch at all, because they're parallel, that's no solution. Well, so infinite many solutions means that where they touch, because they're on top of one another, is they touch here, 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 here. Right? They touch all over the place because they're on top of one another. So that's why we say infinite many solutions. So I guess the other way to think of this is if the numbers match, then it would be infinite many solutions would be your answer. Now, what if you got something where the numbers didn't match? So let's say, just for example, and just so you can get a preview of what you're going to see in the next problem, is that let's say you did all of that and you got down and you got negative 7 equals 12. Well, no, that's not true. Negative 7 does not equal 12, so that would be false. That's where it would be a no solution. All right, so try number 6 in the middle. See what you come up with. All right, so let's check number 6 in the middle. You should have got no solution, so you should have got something that was a false statement. If that's what you got, go ahead and pause. Try number 6 on the right side. If you didn't get that, then let's see why no solution would be the answer. So we're going to do our substitution. We're going to replace. We're picking up negative 7x minus 3. We're dropping it off right there on the y. So we're going to copy down everything we see from that second equation, 21x plus 3. But the difference is y is going out of the game, and who's coming into the game for him is negative 7x. It's a sad-looking 7. What is that? Can't come into the game like that. Got to come in strong. All right. Negative 7x minus 3 equals to negative 2. When I do that distribution, right, so I'm going to distribute that positive 3. So that ends up being 21x minus 21x minus 9 equals negative 2. So let's see what cancels there. Well, if I had 21 x's and I took 21 away, I have nothing left. And then so I've got negative 9 equals negative 2. Well, that's not true. Negative 9 is not the same thing as negative 2. The numbers don't match. That's false. So what that would be then is that would be no solution. So that's how we ended up with the no solution there. And by the way, we kind of show the that they not equal to, right? So we're showing that they're not equal to, and that so that our answer would be false. No solution. What does that mean about those two lines? What that means about those two lines is that if you graph those two lines, we would find that they are parallel, right? So two lines that don't touch, they don't touch. That means there's no solution. All right, so try number 6 on the right side. And just checking to see number 6 on the right side, should have that done by now. Should have got true. Should have got infinite many solutions. So you should have got, when you did the substitution, should have got that the two numbers matched. All right, so making some progress. Hang in there. We're almost there. So number 7. So now you notice number 7, there's nothing for me to substitute. Because, see, I don't have the x or the y. Nothing's by itself. You notice that x and y are actually lined up together, right, on the same side. So x and y and x and y. Well, so this is a different type of method that we're going to use then. Because the substitution, we have to have it where one of the equations is in slope-intercept form, or at least where one of the equations has a variable that's isolated or solved for itself. So what we're going to do here is that we're going to use a method called elimination. Now you might notice our former governor over there on the right side, right? So he's the terminator. Well, so what we're going to do is we're going to be the eliminator, and we're going to eliminate, right? So you think about what eliminate means. It means to get rid of. If a team got eliminated from the playoffs, that means they're gone, they're done. So what we want to do is that we want to eliminate. Let me just take a look at the little note that I made over here on the right side. We want to eliminate x or y by making one of them opposites. Now, they actually may already be opposites. And you're like, well, what do you mean by opposites? Well, when we talk about opposite, what we mean is that we're just looking for something that's the same number but has different signs. That's all we mean. So if you look at this one, if I say, okay, well, do I have any opposites? Well, 4 and no, that's not opposite. Oh, okay, these are opposite. Same number, just with different signs. So what we're going to do with this, and I think you might actually think this method's even a little bit easier, is that we're just going to add those two equations together. So instead of taking one equation and stuffing it into the other equation, like with substitution, what we're doing here is we're taking two equations and kind of thinking as we're smashing them together. And this is really a 1 in front of this x. Let me write that 1 in there. And then so 1x plus 4x would be 5x. And then what ends up happening is that 6y minus 6y, well, those eliminate, right? They cancel each other out. They're gone. And then what we want to do is we want to add up everything else. Negative 3 plus 18. I have more positives. And to find the difference between the two, I subtract, right? The bigger number minus the smaller number. So 18 minus 3 is 15. And again, they're positive, so that'd be a positive 15. And then let's divide both sides by 5, so we get x equals 3. Now we're still looking for where these two lines cross, right? So it's still the same idea. We're trying to figure out where these two lines cross without actually having to graph. We're just, again, doing it without graphing. Now, you still need to know what the y is, so we still have to substitute this x into one of the equations. Again, doesn't matter which one we pick. We said pick the one that looks easier. I'm going to go with the top one. Looks like there's a little bit less going on with that one. What happened with the y's again, by the way, is they eliminated. So that's why the eliminator, hasta la vista, opposites. Right? So that's what we're getting rid of. We're getting rid of the opposites. X plus 6y equals negative 3. By the way, I know my Schwarzenegger impersonation's awful. I promise you I won't torture you with that. And then let's see. Let's do the substitution here. Maybe not that bad. So let's say x equals 3. And we're going to substitute. Right? And why am I dropping it off there? Well, because it says x equals 3. Right? I'm not plugging it in for y. I'm plugging it in for x. So that would be 3 plus 6y equals negative 3. And then I just need to get y by itself. Let's get rid of this 3. So I'm going to take 3 away from both sides. If I had 3 negatives and now I've got 3 more of them, now I've got a total of 6 of them. And then I want to divide both sides by 6. So I get y equals negative 1. So when I go together to put my final answer together, I would have 3, comma, negative 1 as my final answer. Be careful too on the test. These people are evil. They'll try to trick you. So they'll do something like this. Like they'll write negative 1 comma 3 as one of the choices. Don't fall for that. You know that x comes first and then y. So yeah, don't let them trick you on that one. All right, so try number 7 in the middle. And by the way, number 7 in the middle, oh, and I should have told you this earlier. Let me go ahead and mention this to you now. Number 7 in the middle, you'll notice is the same as the one we just did, and that's true for the one on the right as well. So there's actually a typo there. So if you'll copy this down, number 7 in the middle should be, and so scratch out what's on your paper. Number 7 in the middle should be 3x minus 8y equals negative 17, and negative 8x plus 8y equals negative 8. Maybe pause that if you need to copy that down. And then just before I show you the answer, and then number 7 on the right side, again this is number 7 on the right side, would be 2x plus 2y equals negative 8, and negative 2x minus 3y equals 16. So sorry about the typo there. I fixed it, but you may have one of the older copies where that's there. All right, so well, try number 7 in the middle and see what you can do with those. Okay, so let's see what you did with number 7 in the middle. Should have got 5 for your x, 4 for your y. And if you got that, great. Go ahead and pause it. Try number 7 on the right side. If you did not, then, well, let's take a look at it together. So again, we're looking for opposites. And again, we know this is a little bit different. We're not doing that substitution thing because we don't have either x or y by itself. You see how the x's are lined up and the y's are lined up. Well, when it happens to be that the problem is set up like this, it's a little bit easier to use this method that we call elimination. So what elimination involves is really just adding the two equations together, kind of smashing the two together. And what we're looking for is we're looking for opposites. And so for us to be able to cancel something, we need the same number just with opposite signs. Well, 3 and negative 8 aren't even the same number. Oh, okay, negative 8 and positive 8. And by the way, you know, sometimes it's the x, sometimes it's the y. Let's see, what was it on that last one? Oh, it was on the y as well. So I don't want you to think that it's always the y. I mean, it just, you know, it just changes. So let's see what we've got, right? You have more negatives. So I subtract. 8 minus 3 would give me 5. And there are 5 negatives that I have more of. I have 17 negatives and 8 more negatives. So that gives me a total of 25 negatives. I'd have to add those together. And then I'm going to divide both sides by negative 5. So we get x equals 5. Remember when you multiply and divide, same signs positive, different signs negative. Alright, so x equals 5. Let's do my substitution. I'm going to show you the bottom just because it seems like we've been doing the top a lot. So I just want you to know it doesn't matter which one you pick. I'm going to mix it up here a little bit. And we're going to try the bottom one. So let's take x, because we know what it is now. It's equal to 5. And we're going to substitute that in right there. So you notice, again, I'm using the different colors, so you see where the substitution is taking place, where I'm replacing that number. Plus 8y equals negative 8. Negative 40 plus 8y. Be careful at this point, by the way. It's really easy to make some tiny little mistake as you're just kind of flying through here, maybe not thinking about what you're doing. So just be careful at this stage of it. 8y equals, let's see, what do I have more of? I've got more positives. And then to figure out how many more positives than negatives, I'd have to subtract. So 40 minus 8 would be 32. And we're going to divide both sides by 8. So we get y is equal to 4. So for our final answer, x first as always, we would have 5 for your x and 4 for your y. Alright, so go ahead and pause now. Try number 7 on the right side. And let's see what you got for number 7. Should have it at this point. Number 7 on the right side should have positive 4 for your x and negative 8 for your y. Alright, well, so let's go ahead and move along to number 8. So if you look at number 8, x and y are still on the same side. They're in standard form. They're not in slope-intercept form. So I'm going to use this method called elimination. Now here's the deal. If you look at this one, you're like, okay, let me cancel, but, oh, wait. Right? Because those aren't opposites, and then those aren't opposites. See, if you added it up as it is, and don't write this down, but if you added it up as it is, you'd get negative 2x plus 3y equals 10. Well, the whole point of this thing is we're trying to get it down to just one variable, either just x or just y. Well, that didn't do anything for us. So we got to kind of rethink this. So what we want to do is the eliminator is telling us over here is that we need opposites. Well, if I don't have opposites, I need to make opposites. How would I do that? Well, how I would make opposites is that I can multiply one of the equations by a number to change it so that I do get opposites. What I mean by that is, let's look at the y's here, for instance. Right? If I looked and if I said, well, what would need to be, I'm going to pretend that's not there. Don't cross it out on your paper. We're just doing a little pretend here. Right? So you say, well, what would need to be underneath a plus 6y so that they would cancel? Well, that would be a negative 6y that would need to be there. Well, I don't have a negative 6y. So then I say, well, how can I take this negative 3 and turn it into a negative 6y? Well, if I multiply by 2, that would turn it into a negative 6y. But here's the deal. As with a lot of things in math, is that what you do for one, you got to do to the other. So we got to distribute that 2 to everybody. So you can't just change one. So you notice that the top one stays the same. Negative 6 plus 6y equals 12. It's just the bottom one that changed. So the new one there would be 8x minus 6y equals negative 4. And I would encourage you, by the way, to draw this arrow as I've done here, because it's really easy to remember to multiply the one that you're trying to change, but then maybe you forget to go all the way across. So you make sure you want to do that. So what you're doing there is you're looking at the smaller number and you're saying, what can I do to the smaller number to make it look like the larger? Well, to take negative 3 and make it look like a 6, we just need to multiply by 2. Now you notice over here, you say, well, why didn't we do the x's? Well, there's nothing I can multiply 4 by to make 6, so that's why we didn't use the x's there. Alright, so now at this point, this is exactly the same as what we just did. There's absolutely nothing different. Hasta la vista, right? So the y's are gone there. And then let's add the rest of this stuff up. So you get 2x, right, because I have more positives than negatives, equals 12 minus 4, which would be 8. And then so x equals 4. And again, at this point, it's exactly the same. You wonder, okay, when I do my substitution, which one do I go back into? Do I use these ones over here? Do I use these? Again, the answer, it does not matter. Just pick one. And again, just pick the one with the smaller numbers, right? That's usually what I go for. So I'm going to try the bottom one there. 4x minus 3y equals negative 2. And then I'm just going to do that substitution. So I'm going to take x and drop it right there. And drop it, not like it's hot. I don't know, it's written in red. Maybe it's hot. So let's see. 4 times 4 would be 16. 16 minus 3y equals negative 2. So we're going to subtract 16 from both sides. Negative 3y equals, so if I have 2 negatives and 16 more negatives, that means I have a total of 18 negatives. And then if I divide both sides by negative 3, I would get y equals positive 6. So for my final answer on that one, I would get 4, 6. All right. Well, so we're almost there. Try number 8 in the middle, and then see what you come up with. All right, so let's check number 8 in the middle, see what you got there. Should have got negative 1 for your x, positive 2 for your y. If you got that, great. If you didn't get that, then let's take a look. But if you did get it, go ahead and pause now. Try number 8 on the right side. If you did not, let's see what happened. So again, you're trying to make opposites. You're trying to make either x or y opposites. It doesn't matter which one. And again, opposite just means that you're looking to make something have the same number just with different signs. So if you look at the problem as it is, you'll see that 10 and negative 5, they're different signs, but not the same number. Negative 3, negative 5, they're not different signs, and they're not different numbers. So what you look at is you look at the smaller number and you say, well, what can I do to the smaller number to make it look like the larger number? So for instance, I'd say, well, what can I do to 5 to make it look like a 10? Well, I can multiply it by 2. But so the thing is, I can't just change the 1. I got to multiply across to everybody. Now the top one stayed the same, so I'm not going to do anything different there. I've got 10x minus 3y equals negative 16. And then on the bottom, I've got negative 10x minus 10y equals negative 10. And then I'm going to add that up. And who am I going to say hasta la vista here to? It looks like the x's, right? So hasta la vista. They're out. Let's see how many y's we got. You got 3 y's, got 10 more y's. They're negatives, by the way, right? 3 negatives, 10 more negatives to give you a total of 13 negatives. And then if you look at the numbers, you got 16 negatives and 10 more negatives, so you got a total of 26 negatives. And then we just want to solve for y at that point, so let's divide both sides by negative 13, and we get y is equal to 2. Again, just pick one. When you go back in to figure out which one it is, it doesn't matter which one. I don't know, maybe I'll just go with the bottom one there. Again, does not matter. Negative 5x minus 5y equals negative 5. So let's take that y, because we know what y is equal to now, and let's do the substitution. I'm going to plug it in right there. So what you end up with is negative 5x minus 5 times, let's drop in that 2, equals negative 5. And again, using the different colors so you see where I'm making the substitution or the replacement. Negative 10. And then you're just trying to get x by itself. Opposite of a minus 10 would be a plus 10. Do that to both sides. Bring down the negative 5x. And again, you ask yourself, what do I have more of? Do I have more positives or do I have more negatives? I have more positives. And you say, okay, well, how many more positives do I have than negatives? So I've got 5 more, right? Because you subtract 10 minus 5. And then let's divide both sides by negative 5. And you get x equals negative 1. So for our final answer, as we've got up here listed already, negative 1 for your x and positive 2 for your y. So your answer there would be negative 1 comma 2. All right, so it's your chance to try this on your own. You're a big kid. You can do it. So let's see what you get for number 8 on the right side. So let's check number 8 on the right side. What you should have had there would be negative 2 for your x and negative 1 for your y. So negative 2 comma negative 1 is what you should have had. All right, well, it's coming to an end. I know you're sad. There's only 2 left, number 9 and number 10. But we're almost there, so hang in there. Good work so far, by the way. I can see through the screen, by the way, so I don't know if you know that or not, but I can actually see through the screen and see that you're working, so good work. All right, so let's try to, what's the Terminator, what's he say over there? He says we gotta make some opposites. Well, so, I don't know, let's see if we've got some opposites or not. Well, positive 4, negative 3, those aren't opposites. Negative 6 and positive 8, those aren't opposites. Well, is there anything I can multiply 3 by to make it a 4? No. Is there anything I can multiply 6 by to make it an 8? No. Oh, okay. Well, so what I have to do is I have to come up with a number, since the smaller one won't go into the bigger one, then I have to come up with a number that they would both go into. So for instance, what I mean by that is that 3 doesn't go into 4, but then I've got to come up with a number that 3 and 4 both go into, so a number bigger than they are. Well, if I think about the multiples of 4, right, because you have 4, 8, 12, like if you were counting by 4s, right, 16, 20, and then if you did the multiples of 3, which again, you don't have to write this, 3, 6, 9, 12, 15, and so on. Oh, okay, so you see the number that they would both go into would be 12. Let's get that out of the way. So what I could do is I could multiply, if I wanted to make that a 12, I just would have to multiply by 3. And I got to do it to everybody. And on the bottom, if I wanted to make negative 3 a 12, I would have to multiply everything by 4. And again, because my goal, what I'm trying to do is I'm trying to make these things opposites. I wanted one to be a positive 12, and I wanted one to be a negative 12. Well, so let's multiply across the top there. So 3 times 8y would be 24y. And then 3 times 4 would be 12. And then on the bottom, you've got 4 times negative 6, which would be a negative 24y, and then 4 times 6, which would be 24. All right, so let's look and see what we can cancel. Oh, okay, look, the x's cancel. Oh, hey, wait, the y's cancel too. What's left? Well, there's nothing left. Our number for nothing is 0, equals, and then let's add these together. 12 and 24 make 36. Well, so we've already looked at the situation like this when all the variables are gone and then you're left with just two numbers. So then what you're left with asking yourself is that a true statement? Does 0 equal 36? No, it does not. 0 equals 0. 36 equals 36. Those numbers do not match. So if the numbers do not match, if you get something that's false, then your answer would be no solution. So what this problem is letting you know what it would look like if you're using elimination and you got one of these special cases, either the no solution or the infinite many solution. Okay. All right, so 9 in the middle and 9 on the right side, by the way, is the same thing. It's either going to be no solution or infinite many solution. So check it out, see what you come up with. All right, so go ahead and pause now. All right, so let's see what you got with number 9 in the middle. Should have got true. So should have got a situation where you got 0 equals 0. So that would be infinite many solutions. And again, what that means is that those two lines, if we graphed them, would be on top of one another is a way to think of it. All right, so if you got that one right, great. Go ahead and try number 9 on the right side. If you didn't, let's double check. And if you had problems with this, by the way, I'm guessing it was just maybe trying to figure out, like, wait, what do I need to multiply by? So again, you start with the numbers, and I start with the smaller one. Because let's not make more work for ourselves than what's necessary. So yeah, I could think about how I could turn, what number I need to turn 6 and 9 into, right? Because 6 doesn't go into 9, but they both go into 18. But maybe we'll just think of the smaller number, right? Like 2 goes into 3. Well, there's nothing I can multiply 2 by to make 3. But if I wanted to, a number they both go into would be 6. So let's say I wanted that to be a 6x, and then let's say I wanted that to be a negative 6x. Well, and then I'd have to think about, well, how can I make that happen? If I were going to make that happen, how would I make it happen? Well, for the top, I'd have to multiply 3 times 2 to make that 6x. And then I'm going to multiply everything else, right? Negative 18y and a positive 18. And then on the bottom, if I want to think about, well, how can I turn negative 2 into a negative 6? Well, I'd have to multiply by 3. So let's distribute that across and multiply by 3. So 3 times negative 2x, negative 6x, that's what I wanted. 3 times 6y, a positive 18y. And then 3 times negative 6, which would be a negative 18. So notice what happens here. Bam! There goes the x's. Bam! There goes the y's. Oh, and 18 minus 18, well, that cancels as well, right? Because 18 minus 18 is 0. So what you're left with is 0 equals 0. Well, so in that case, that's why the answer, because the numbers match, because that is a true statement, that's where we get infinite many solutions. All right, so pause now. Try number 9 on the right side. And once you've paused and you've got number 1 on the right, let's see what you should have got. Should have got another situation of an infinite many solution. So when you multiplied, should have got 0 equals 0. All right, well, we saved the best for last. I know you're excited about this. Number 10, the word problems. But we're actually going to show you, I know you probably have a fear or phobia around word problems, but I'm actually going to show you that this actually isn't too bad. Let me kind of point out something before we really get into the problem. All of these problems that we're going to look at here, they have kind of the same setup. You notice at the top right here, I wrote first item plus second item equals total items. What they're going to do is they're going to tell you some story. Somebody goes out and buys some stuff. So the first item is just going to be the first thing you buy. The second item is going to be, you're going to buy some of one thing, and then the second item is some of the other thing that you're going to buy. You don't know how much of each thing that you bought, but you do know that they'll tell you the total number of items you bought. And then they'll tell you how much each thing cost, right, first and second item. And then they'll tell you the total cost that you spent. But what you don't know is you don't know how much of each thing that you bought. So you have to first, I think the first thing is identifying, what are we buying? What are the items in this particular problem? So you'll notice this guy's having a graduation party. Yay, Patrick. And he's buying packages of paper napkins and paper plates. So it says the napkins cost $6, and then the plates cost $12 per package. And then it says that he bought a total of 15 packages and paid a total of $132. So let's just get kind of a little visual on this. And I got some napkins and plates here, right? So here's your two items. You bought some napkins plus you bought some plates. There we go. And yes, those are Hello Kitty plates. Don't hate. Patrick wanted some Hello Kitty plates for his graduation, so it's his big day, so we'll let him have it. So we bought some napkins, we bought some plates. So you got some napkins, you got some plates, and then we just want to know how many total did you buy? Well, you bought 7. Let's see, it says you bought a total of 15. Right, so that says 15. Now what we want to do is change that into an equation. So instead of using x and y, we can use letters that fit with the problem. So what we could do for napkins, right, that starts with an N, is that we could use the letter N, right, for napkins. And then since plates starts with the letter P, how about we use plates, or I'm sorry, P for plates. So what you would have, your first equation there would be N plus P, the number of napkins plus the number of plates, is equal to 15. Now, so let's see how much each thing cost here. So if I brought down, actually I should have copied this. Let's give me 1 second. I'm going to pause. All right, I just did a quick edit there. I just wanted to set that up a little bit better. So there we go. So we got number of napkins plus number of plates is equal to 15. We don't know how much of each, but we do know if you took the two things together, it's 15. Now, the other thing is the cost, and this is the second one's kind of the money line, which is how much does each thing cost? Well, so it says that you paid a total of $132. Napkins cost $6. So what we can say is it's $6 for each napkin. And then it says for plates, look back over here, it says plates cost $12. And then the total that we bought was, we spent rather, was a total of $132. Now the thing is that I can't say, 6 plus 12 is not equal to 132. That doesn't make any sense. Well, it's $6 per napkin. And again, I don't know how many napkins, so we're going to put in N. 6N plus 12P. So that would be my second equation. So I've got 6N plus 12P equals 132. What I'm looking for is, the question says, how many plates did Patrick buy? So if they're saying how many plates, what they want us to do is they want us to solve for P. That's what that means. Solve for P. Now we could solve for both. I mean, we could solve for N and P, but the question just asks for plates. Well, if the question is just asking for plates, right, what they're saying is we just want to know what this is equal to. Well, then what they're saying is we don't care what the number of napkins are. So that's what we're going to choose to eliminate. So if we choose to eliminate something, we're going to eliminate the napkins because they want to know plates, not napkins. And then so you go back to it and you say, okay, well, what can I do to cancel with a positive 6, right? I need these two things to cancel. I need them to eliminate. Well, this would need to be a negative 6. But the thing is that I can't just change one. I got to change everybody, right? So that would go all the way across. And so I would have a new equation, which would be negative 6N minus 6P equals, and then you've got 15 times 6. You don't have to do everything in your head, by the way. There's nothing wrong with coming to the side, doing a little scratch work. 5 times 6 is 30. Carry the 3 there, right, which would be 90. So don't just try to guess in your head if you're not sure. Just multiply it out. And then the bottom one would be 6N plus 12P equals 132. All right, now we've got our equation set up. What we can eliminate, let's eliminate the N's, right? So we can eliminate that. And then let's see how many P's are left there. We've got 6P. And we've got 132 minus 90. Now you have more positives, so the number would be positive. And that should make sense. We can't have like negative plates. That doesn't make any sense. So maybe we'll just do some more scratch work over there if you're not quite sure. There's that 90. So let's say you've got 132 minus 90. Well, that would be 2. Can't take 9 away from 3. You need to borrow. So that would become a 13. So I'd have 42. All right, so let's divide both sides by 6, and so we get P is equal to 7. So what that means is that there were 7 packages of plates. It's a lot of Hello Kitty plates, but you got to stock up on that stuff. So you get 7 packages of plates. Now you could figure it out, right? I mean, if that means that this is 7, and we wanted to know how many napkins, well, if there's a total of 15, that means that the number of napkins would have to be 8, because 8 plus 7 is equal to 15. But we don't need to know napkins. I'm just saying if we needed to, or if we wanted to. All right, so try number 10 in the middle. We're almost there. You've made it this far. Hang in there. The end is in sight. Let's try number 10 in the middle. All right, well, let's check in, see what you got with number 10 in the middle. Number 10 in the middle, they were asking for how many people rented skis. So how many people rented skis? So there's a total of 18 people that rented skis. If you weren't quite sure what the answer was on that one, hang on here. We'll go ahead and show it. By the way, if you did get this one correct and you want to know what the answer to 10 on the right side is, the answer is 4 adult tickets. I used A for adults. So number 10 on the right side, there's 4 adults. But let's go back to 10 in the middle, see what you should have come up with there. All right, so again, I told you 2 different items. Now, the items maybe kind of change a little bit depending upon what the story is. This particular one says is that some people are going to go the Pacifica High School Band. There's going to be some people that are going to go to Big Bear. So it says that they can rent skis. So we can do skis for 16, or you can rent a snowboard for 19. And what we know is there was a total of 28 people that go on this trip, and we paid a total of $478. So let's kind of line it up in the same way, because I know for some people, word bombs can be kind of difficult. So let's line it up in a similar way here. I'm going to use little pictures, because I think pictures make it a little bit easier to understand. So there's some number of skiers. We don't know how many. Out of the group of 28, we don't know how many people skied. We just know that some of them skied, and then some of them snowboarded. But we know that since there was a total of 28 people that went on the trip, that there was a total of 28 rentals. Because whoever skied plus whoever snowboarded, and the total people that went on the trip. Now, the other part of that is the cost, right? So let's kind of start thinking about the cost on that one. Let me duplicate my little skier guy. Let's duplicate Mr. Snowboard Man. All right. Now, you might, on the other one we used napkins and plates, so we used N and P. The problem here is that, snowboard and ski both start with the letter S, so that's probably not a good idea. And by the way, S isn't a good variable anyways, because S looks like a 5. So what you can do in this particular case, it doesn't really work out as well. So what we could do if you wanted to, you could use any letter you wanted. But, you could also just use X and Y. That's another option as well, is maybe use X and Y. So I'm going to say that these guys are X, those guys are Y, and so that gives me my first equation, which would be X plus Y equals 28. And then let's talk about the cost. Let's look at the money line here. So the money says that it's $16 for a ski guy, so we'll do 16 for that guy. And then as far as the snowboarder, it says 19. So it'll be 19 for that. And then the total cost on it, if you add those two things together, so it's saying that we spent a total of $478. And again, for the skier, we're using X, and for the snowboarder, we're using Y. So that'll give you your second equation, which would be 16X plus 19Y equals 478. Now let's see what they're looking for. They said how many people skied So we're calling skiers x. So what we'd want to do is we'd want to solve for x. Solve for x. Or whatever, and you could have picked a different letter, so it doesn't have to be the same letter. You got to make sure you know which one's which. That's all. You got to label it. All right, so if you want to solve for x, that means we want to get rid of the y's, which means that we want the y's to be opposites. Well, so I look at it and I say, well, how can I make a positive 19 go away? Well, that would need to be a negative 19. So what I'd have to do is I'd have to multiply the top by a negative 19. Now, don't be scared of the numbers here. I know the number's a little larger, but that's okay. We'll do a little scratch work if that's what we need to. Negative 19x minus 19y equals, and let's, like I said, do some scratch work. So 28 times 19, I'll kind of come over here with it. So we got a 2. 18 plus 7 would be 25. 1 times 8 would be 8. 1 times 2 would be 2. Let's add all that up. So that would be 13. Carry the 1. So you get 532. Okay. So what we end up with there is we end up with a negative 532. And now the bottom equation stays the same. You've got 16x plus 19y equals 478. And let's see what we can cancel. So as far as what we can eliminate, what we can cancel is we can cancel the y's, and then let's see what's left over here. I have more negatives, so that's a negative 3x equals, now 532 minus 478, and there's more negatives, right? Well, let's see, I can't take 8 away from 2, but I can borrow, right? So that would become a 2, that would become a 12, so that would be a 4. Now I can't take 7 away from 2, so I'd have to borrow again. So that would become a 12, and so I'd end up with 54. And then I'd have to divide both sides by negative 3, and so we get x equals 18. So what that means is the number of people that skied would be 18. Now, if this is 18, again, you can figure out how many snowboarders, right? Because if there's 18 skiers, how many people snowboarded? Well, 10, right? Because 18 plus 10 is what would give you the 28. Well, so hopefully by using some pictures there, we made the word problem a little bit easier. I think if you do see kind of a picture of it, I think it's a little bit easier to kind of lay out. All right, well, this is it. We're done. Try number 10 on the right side. What you should have got, whoa, too far. What you should have got with number 10 on the right side would be a is equal to 4. Well, so at this point, we're done. So what you want to do is you make sure you have this whole study guide complete. Really appreciate you being here today. Appreciate you taking the time and effort to come in and raise your grade and working hard. I promise you it'll be worth it when you see your grade go up. So make sure this is complete, and then what you do is just let me know that you're ready to take the test, and then you'll take the test. All right, well, thanks for being here, and good luck on the test.